Hi there. Welcome back to another video in BCIT's Technology Teacher Education 4010 class. This is an introduction to eventually microcontrollers, but right now we're starting out using VEXCode VR. And today we're actually going to take a look at a solution to a problem that I posted in a previous video where I asked you to think about creating a subroutine or a block, as they call it in VEXCode VR, to create a circle of a given radius or diameter. The math works out kind of the same. You just don't have to multiply by 2. So anyway, we're going to start with a routine to draw a circle of radius r. And as soon as this camera focuses in right here, hello camera, I may be zoomed in a little too close right there. Let's just move that back out a little bit and yeah, that's going to make the video less interesting if you can't see what's going on. There we go, drawing a circle in VEXCode VR. Um, so before we start writing a lot of code, I like to sit down with pen and paper or pencil and paper and draft out what it is we want our robot to do. And in the last video, we were taking a look at how we could draw polygons, and we could make polygons with multiple sides in them. And when you think about it, all a circle is an infinitely sided polygon. Now, we don't really have a function for drawing infinite sides. It would probably take a while to do, but we can approximate that and get pretty close. And what I'm going to suggest today is that a 360-sided polygon corresponding to our 360 degrees in a circle is probably going to work out pretty well for us here. So if we're going to create a circle, then what we're going to do is we're going to bring in, turn on a bit of light here, that might help it focus. There we go. If we're going to create a circle, we're going to pass a variable in, and that variable can be the radius or the diameter. I'm going to use the radius r is going to be passed in there. And that's going to be the radius of the circle in millimeters on the VEX display, okay? And what we're going to do is our robot will be sitting at any given position on that chart, and it'll have an X and Y coordinate, and it'll know what it is. And what we want to do is we want to draw a circle about that point, and that circle is going to have radius r. Okay, so if we're starting at this point right here, the first thing we need to do is we need to drive out to the edge of the circle. Now, the cool thing about circles is it doesn't matter which way you're pointing because, well, if you drive out this way, you get to the edge of the circle. And if you drive out this way, you get to the edge of the circle, aside from the fact that I didn't draw a very good circle right there. Okay, but the radius is the same in any direction, so it doesn't really matter. So you can just tell your robot to start by drive r millimeters out to the edge of the circle. Now, when you get there, your little robot will be pointing that way. So the next thing you need to do is you need to turn 90 degrees. Okay, now you can choose right or left. It doesn't really matter. Do you want clockwise or counterclockwise circles? In fact, if you're creating a generic circle drawing program, you might include that as one of the variables that gets passed into your subroutine. A 1 for clockwise, a 0 for counterclockwise, and you could have multiple variables passed into here. But we're just going to turn 90 degrees to the right. There's no particular reason I've chosen right. You could go left. So now our little robot is going to be sitting in here and facing in this direction. And then we want to draw a 360-sided polygon coming all the way around here. Okay, well, it's 360 degrees around the circle. So each time you move forward, you're going to need to turn, but you're sitting there, how far forward do I have to turn? This is hopefully not a problem that's causing you a lot of mathematical grief. because we know the circumference of a circle is pi d or 2 pi r. So your entire distance around here equals 2 pi r. Okay, and if we break that down into 360 chunks, you can just take 2 pi r and you can divide by 360. So this little segment that you're going to drive right in here is 2 pi r over 360. And then you'll turn 1 degree, and this little segment that you drive in here will be 2 pi r over 360. And that little segment will be, and you can see this pattern. And one of the things that we like to do in programming is we like to identify patterns and figure out and say, oh, we've got a pattern right here. So after we've turned, let's put our pen down. The robot pen, not my pen. And so that we start marking out our circle. And then what you're going to do is you're going to drive 2 pi r over 360 millimeters forward. And then you're going to turn 1 degree. And this chunk right in here, you're going to repeat 360 times. Now, after you've done 360 segments like that, you'll have come all the way around the circle and you'll be right here. You're not quite back at your starting point, so you can go pen up. Then we turned 90 to our right up here. If we turn 90 to our right again, we'll be facing back to the middle. If you turned left to get start and drew your circle coming this way, you're probably going to want to turn left now. And then you're going to drive r millimeters forward. And that will bring you right back down here. Now, if you started pointing this way, now you'll be pointing in the opposite direction. If that concerns you, you can always turn 180 degrees and you'll be facing back in the same direction at the same position that you were when you started drawing that circle. So let's see what that takes a look like if I remember to click on the button and make this go full screen this time. I've just dragged it full screen on one of my screens here, but now I transition over here so that we can take a look at this on the screen that's being recorded here. So, okay, what have I got right here? Well, this is my block or my subroutine over here. And as you recall, we created the block by coming down on here and clicking on the Make a Block button. And that gave us this block. I typed in circle for the name, and I added an input right here. And the input is the variable that's going to be passed into that routine. So we did that, and that was where that pink block that said circle came from. And you can see right in here that I drove forward for r millimeters. That was how we got out to the edge of the circle. And to get that r in there, you just pick it up off of the circle and drag it into that little hole right there. Don't leave it sitting right there. You just go away somewhere. I don't need you there. Okay, then we turned 90 degrees to get, facing onto the tangent of the circle. We put the pen down. Here's our repeat 360 command right in here. So we're going to do what's inside here 360 times. And then we're going to drive forward. How far are we going to drive forward? Well, in order to do that, it's a little bit of a hassle to build up your equation. You need to find your math things down in here. And so we're going to do a multiplication to begin with. And so you have to drag the multiplication in there. And then because we're doing 2 pi r, you need another multiplication in there. So you're going to drag that in there. And notice when I drag that over top of there, the little white section there highlights and plop. That'll plop into there where that's been highlighted. And then we need to do a divide right in here. And so now I can drag that in there, and I've got multiply, multiply, divide all in sequence. So then I was able to punch in 2 pi drag R from down right here and punch in 360. And then when you go to pick this up, just careful where you grab it, because if you grab it at the beginning, that middle part's going to pop out. You kind of need to grab it out at the end right here and then drag it up. And if you're going to put it in there, for instance, I don't want it there, but if I was, you can see I keep going until that little rounded end thing highlights in there, and I can put that right into there. I'm just going to get rid of that because I've already done that right here, 2 pi. And just for a little bit of precision, instead of using 3.14, I use 3.1415927, an approximate value of pi. Every value of pi is approximate. Right in here, I was experimenting with different degrees right in here. We're going to turn right 1 degree in this example. We're going to take a little bit of a look at what that happens. That's going to do that 360 times. And when we're all done, we lift up the pen, turn right 90 degrees and go back to the middle. Okay, I don't need that block in there. All right, so now, because we've got a circle function over here, or a circle block, we don't need to tell the main program how to build a circle. It already knows. It's like we've got a new command over here almost that we can use. In fact, we do. If you look at how that's listed, that circle command is sitting right down here. It's like you've taught your robot how to do something. So now you don't have to give it all the instructions. You just say, hey, robot, circle, go make me a circle. You figure out how to get it to mix you a drink, let me know. So anyway, when the program starts, you'll recall we had a couple of settings in here for drive velocity and turn velocity. And these are our initialization settings. And it's important in any type of program that you've got somewhere at the beginning of your program to set up your parameters, say what your variables are going to be. And certainly when we get on to programming our Arduinos, you'll see that that's formally encoded right into the Arduino software that you're going to have a setup setting right in here. And this is what I use to move us right to the middle of the screen, okay? Then we come in here and we've got a variable called x, and we're going to go 10 times. We're going to create a circle of radius x. Here we've set this to 100. This number, whatever's in here, gets passed over to here to control our command, runs through there and does what it says. And then we come back here and we change x by 100. So each time we go through here, x is going to keep getting a little bit larger and a little bit larger and a little bit larger. So let's take a look and see what that looks like. Let me drag that up onto the screen. And there we go. So it came out here, it drove to the center of the screen, and during our initialization, came up here, put the pen down, and now you can see it's kind of going in start, stop, jerky little motions right in here as we cycle right through here. And that's actually pretty representative of what our commands are telling it to do, because our commands are telling it to drive forward and stop, and then turn, and then drive forward and stop, and then turn, and drive forward and stop and turn. And you'll notice that the robot seems to be moving really slowly. Well, that also makes sense, because if you think about how you move as a person, if you're moving in tiny little increments and someone says move forward 1 inch and then stop, move forward 1 inch and then stop, and you're stopping every inch, you're not exactly going to win the 100-meter dash, especially if you're moving in inches and racing in meters. Anyway, it's coming out here and it's doing this. Now, there are things that you can do so that it doesn't stop at the end. Okay, and those have some interesting consequences when you get in here, and there's ways you can optimize this, but VEXCode VR actually does a pretty good job of emulating a real-life robot. So here you go. You can see that we're drawing a couple of circles in here, and this is going to keep going and going and going and going further forward. I'm going to stop it right here. And you can see that we're going to have a nice little bullseye drawn on our screen. One of the ways that you could make this go faster, of course, would be to use fewer sides on your polygon, because then your robot would be able to move longer distances before having to come to a complete stop, so it could accelerate more. Give it a try. You could replace the 360 right here With 90, you could make a 90-sided polygon and make this repeat 90 times and see what you get as a result. I tried that and it was just a little bit off. Remember, if you do that, that you're going to have to turn 4 degrees on each increment because 90 times 4 gives you your 360. So you still need to complete a full circle to make that into a circle routine. Anyway, one of the other challenges I asked for is that ultimately, when you come to create your circle, if I punch in a circle of radius 1000, let's say we start at 1000, and I'll reset this. And our little robot drives quickly up to the middle right here, comes to a stop, and whammo, goes off the board completely and doesn't do a great job of creating that circle. We kind of get stuck in this routine right here because it hasn't driven forward for those 1000 millimeters because we ran into the barriers and gone off the edge of the board. How would we prevent that from happening? Because quite often, one of the ways people will hack into a computer system is they'll look at where variables are put in and user data goes in, and they'll figure out a way to put in data or code that disrupts the subroutine. So just like right here, this has hung up the subroutine, it's crashed the system, and that might enable a hacker to slip into the code somewhere else. Now, it's not going to happen to your VEXCode VR robot. This is when we're talking about considerably more complex system with many, many subroutines all interacting with each other. But you really want your subroutine to check for garbage data on the way in and make sure that you're not going to run into an error situation like that. Well, where do we run into those error situations? Now, as the robot drives along, it has location data right on here, and it always knows what its X and its Y is right here. So you can check your robot's location data at any time. So before you begin this code, what you could actually do is you could come in here and you could have an if routine. Okay, and where are our conditional routines? Okay, so what you can come in here is we've got all of these ifs, and you can say, let's bring that up here. Actually, let's put it right here. And then we'll only execute this command if something is true. I'm going to get rid of that for just a moment. Okay, well, what condition do we want to be true? Now, let's just sketch this out on paper because that's going to make a lot more sense than figuring it out in code. Oh, I'm on the wrong window again for shrinking things down over here. I move that off to the side like that. And there we go. We're back looking at this again. Okay, now flip over the scrap paper right here, and we have a grid that's set up like this. And right in the middle of your grid is the 0, 0 location. And I believe it is in the VEXCode VR help files, you can double check this, that we've got 900 segments on here. So this would be plus 900, this would be minus 900, okay, and that's in our Y, and then over this way we'd have plus 900, and our X would go to minus 900. So if at any point our command told us that the robot was going to exceed minus 900 or plus 900, or plus 900 and minus 900 in the Y, we wouldn't want that command to execute. Come on, camera, focus, nice. I think the camera's ready for bed now. Okay, there we go. We've got that camera in right there. Now you've got some arbitrary position called X, Y, where your robot's sitting right in here. In this case, you're on the negative X. So say you're at minus 450 and you're in the positive Y. So you'd be at 450, minus 450, comma, say 300 or some number right in there. But it could be any X, Y, and anywhere on the board. Now, if you're going to draw a circle about that point, okay, and you're already at minus 450, the maximum radius of the circle that you can draw before you hit minus 900 is going to be minus 900, okay? What are we doing here? Plus your location. Well, let's start off this way. Let's come in here and say minus 450 minus your radius, okay? In this case, this would be your x minus your radius, has to be greater than minus 900, and minus 450, which is your x, plus your radius has to be less than positive 900, because you've got to be somewhere between right here and right there, okay? And then your 300 minus your radius, okay, which is your positive right there, has to be greater than minus 900, and your 300 plus your radius has to be less than positive 900. Now, this is going to say x, that's going to say x, that's going to say y, and that's going to say y, and we've got 4 conditions that have to be met in order for your command to be able to execute properly without driving off the board. So how would we put those into our code? Okay, pop that code up there onto the screen and transition over there. Okay, now we're back looking at the screen. Well, we've got this if statement up here, and we've got a few things that we need it to do. We need all of these conditions to be true. So when we want to look at conditions being true, we've got 2 main statements that we use a lot of. We've got the or statement and the and statement. Now, in an and statement, everything needs to be true in order for the entire statement to be true. In an or statement, if any one of them is true, then the whole thing's true. So, what you can say if, well, let's take a look at it right in here. We'll put it together in the code. Where are our ifs, ands, and ors? Here we go. Okay, so we've got and statements right in here, and you can drag your and statements. We're going to have 4 of these statements, all of which have to be true in order for our command to execute. Okay, if this is true, and this is true, and this is true, then we're good. And for one of them, we're going to have a greater than statement right in here. And for this one, we're going to have a less than statement. And on this side, we're going to have a greater than statement. And here we're going to have a less than statement. And we said it's got to be greater than minus 900 and less than positive 900 and greater than minus 900 and less than positive 900, so that we don't go off those limits of the board. And then we had a little bit of math where we did some addition in there, okay? And we did addition on the positive sides because that makes our numbers bigger and make sure that we stay within those limits. Okay, and we did subtraction on the negative side. Okay, now this statement starts to get fairly lengthy, but what it's going to do when we initiate the program, it's going to come in here, and before it starts executing this entire subroutine in here, it's going to check and it's going to do our math. And if this condition is true, and this condition is true, and this condition is true, and this condition is true, so if all 4 conditions are met and we're not going off the board on any side, then it's going to go ahead and run our program. Now, to find the position of our robot, that is located right in here. We have location sensing, and so we can drag our position, x in millimeters, and our position x in millimeters. You know what? I think I'm just going to drag this down here because that's going to start getting lengthy. Let's move that up off the, there we go. Doesn't really matter where we put them for right now. I just want you to be able to see this all on your screen in one continuous line. And then we're going to have our position Y. Change that over to Y in millimeters, and our position Y in millimeters. Oh, something got wiped out there. Where'd the minus sign go? This is one of the issues that I have with the drag and drop interfaces. They're great for getting started out, but after a while, I think maybe you'll come as I do to like typing. So if x minus r is greater than minus 900 and x plus r is less than 900, so in other words, we're going to stay on the board horizontally, and x minus r is less than minus, or this is y minus r is less than, then we'll do all of these tests right here. That will check up, and this entire situation will be true. Now, a really good programming practice to get into now is to start adding comments. Okay, and when you come in here and you can add a comment and say, check to make sure we don't go off the board in this routine. Okay, and you can add in here that we're going to move to the edge of the circle. And then in here, you'll drop the pen. Where did my circle command go? Something whipped off the screen, clicked in the wrong spot. There we go. Now that gets up too high. That's where one of our plus statements got to. Okay, so we were adding comments in there, and so we've got that commented up, and now we're still got this set to 1000, which is illegal. That shouldn't work. Let's see if it goes out there and draws the circle for us. Here comes the little robot. It comes out to the middle. Does it draw that big circle? No, it just sits there. Now, that's better than where we were before, where we drove off the edge of the board. Okay, but I'm going to close this right now. It didn't really tell us anything really helpful. What we might like it to do is give us an error message and say, hey, you told me to drive off the board, you idiot, which is a lot more helpful than most error messages you get from computer programs. So what we want to do is, if this is true, we want it to go and do the code. But if it's not true, we want it to give us an error message. And that's why we have little statements in here that say if, then, else. Okay, and so we can bring this right in here, and if, then, else. And what we're going to do is we're going to take all of this code right out of the middle right here. Just copy and paste it right in there. Okay, and let me drag this up right here. Here's our overall statement. I think you kind of have to drag this by the end. You want to make sure you get the whole thing and bring it down there as one piece. Get rid of that if statement, drag this right in there. And now we've got it set up. So if this is true, it will do this. But if it's not true, we want it to do something else. So in other words, if there's an error message, let's have it give us an error message. And let's see right in here, we have a statement where we can say print drive me off the edge of the board, you idiot. because those are the sorts of helpful error messages you like to get from a computer. Okay, now let's run this and see what happens. Goes to the middle, and it's going to drive us off the edge of the board, you idiot. Now, where do we see that statement? There is a print window that pops open, and you can see that from right up here, I think. Where is it in this window? That's our code right there. Ah, right there. So we've got sensors and variables that we can track right in here. So if you ever want to track what's going on in your robot, let's just stop this, close that, and let's not start at 1000. Let's start at 100 and go for our bullseye again. And let's go ahead and run that. And we come out to the middle here. And we should pause this for just a second. Stop that. And there's a way in here that you can add variables in right here so you can track them and see what they're doing. Is it a drag and drop from right here? Do we want to see what R is? No, there's a way you can get that in there. But we do have this text message right down here that if we're going to go off the edge of the board, clicking up here lets you see the messages that come right out in there. So it's a nice way to have feedback into your program. And this is what the code actually looks like. Keep in mind that as we go through and do all of this, there is code being generated. You're just generating it using drag and drop interface, and the computer is turning that into something that it will then take, and it takes all this code and it interprets it and turns it even into smaller and more obscure abstractions until it eventually gets down to the level of machine language, which is very, very simple, very tiny, but very, very fast to execute instructions that affect how things jump around in memory and move around. And although it's a very powerful way to learn to program, we're probably not going to get to that in this course, unfortunately, because it's pretty cool. So there you go. There's a couple of ways that you can go about working on your routines, how you can create a fairly sophisticated routine for circle drawing, and how you can check for error messages and deliver an error message if something goes wrong. This is a point during the class where I'd normally ask for questions, but not seeing any hands. This has obviously been a very clearly described solution. Now, if this is making perfect sense to you and you're rocking along through this and you're going great guns, there is one more thing that might challenge you. And that is, let me just come over here and, right, I've got to hit my mouse on this screen, shrink this down, move it up there, and hit transition so that there we go, we can see right back there. When you're at any arbitrary point on the board, any x, y, we just took a look at how to get your x and y coordinates. If you want to drive to another xy position, call that x1, y1, okay, can you create a routine that would drive you from here to right here? So no matter where you are on the board, you say drive to x comma y, or just, I guess it would show up as drive to x, y, and you can put any two numbers in here and the robot will drive to that point. Now there's a fairly trivial solution. Okay, I'm not going to sketch it out because I want you to figure that out. And there's a more direct solution. And I'll tell you that the direct solution, where you drive from right here in a straight line to this point, is a little trigonometrical. Let's just say you'll want to sit down and think it through. You may run into some interesting little challenges on getting your robot to drive that just perfectly. But have some fun with that. There is a simple solution that will get you there. It just won't get your robot there quite as fast. Okay, so can you create a drive to routine in order to get your robot to move around the board? Alrighty, have fun. And hey, I think I managed to get all my windows working this time. Have a good day.